Okay, let's dive in. You know how pretty much every blockchain out there is, well, completely open,
Yeah, totally transparent.
right? Every single transaction, what a smart contract is doing, it's all visible. Anyone can look it up.
Which is, fundamental for trust and auditing. It works.
It works, but what happens when you actually need things to be private? Like, imagine trying to run a secret ballot vote on-chain.
Or a sealed bid auction. Can't really do that if everyone sees the bids coming in.
Exactly. Or handling sensitive data. That public nature just, it makes those kinds of applications basically impossible on most chains.
Totally. That transparency becomes a real roadblock. I mean, think about finance, healthcare.
Yeah.
So many things need confidentiality. You just can't build them if everything's exposed.
And this is where the source material introduces secret network. It's framed as like the solution for this exact problem.
Right. They call it a protocol with, what was the phrase? Scalable, permissionless smart contracts with a private by default design.
Private by default, that's the core idea, isn't it? Enabling stuff you just couldn't do before on public systems.
That's the big claim. And interestingly, the source says they weren't just theorizing. They were actually the first ones to get private smart contracts running on a mainnet
Oh, really? When was that?
way back in September 2020, apparently. So it's been live for a while now.
Wow, okay. First mover advantage there.
Okay.
So for this deep dive, using just the info we have here, our mission is basically to figure out how this works. How do they pull off this privacy?
Yeah, what's the tech and what does it actually let you do?
And the source also mentioned it's built using the Cosmos SDK. That sounds important for like connecting to other blockchains.
Definitely. Being built on the Cosmos SDK means it's designed for interoperability, especially with other chains in that ecosystem using IDC, that's the Inter-Blockchain Communication Protocol. So it brings privacy, potentially, to that whole network.
Okay, but the core privacy tech itself,
Yeah,
that's the real secret sauce, right?
pun intended. Yeah, that's where it gets interesting. It's not just one thing, it's a combination.
Okay, lay it on us. How do you make a smart contract private?
Well, the first big piece the source mentions is Intel SGX, software guard extensions.
SGX. Okay, I've heard of that. Isn't that a TE? A trusted execution environment?
Exactly. It's like a secure little vault right inside the computer's processor, super isolated.
So a protected zone on the chip itself.
Precisely. Secret Network uses validator nodes that have this SGX capability, and when their version of a smart contract, they call it a secret contract, needs to run,
Oh,
the actual number crunching, the processing, happens inside that secure SGX enclave.
okay.
So the code itself, the data it's working on, the contract's internal memory or state, it's all shielded inside the enclave. And crucially, even the person running the node, the hardware operator, they cannot see inside.
Okay. So the computation itself is hidden. That prevents leaks during the actual running of the contract. That's huge.
It's foundational, yeah. But you're right, data doesn't just live during computation. What about before and after?
Right, when it's being sent to the contract or
Yeah.
just stored.
Exactly. And that's where encryption and key management come in heavily. The source emphasizes this.
Makes sense. Encrypt everything outside the enclave.
Pretty much. Inputs you send to a contract, the contract's stored state, it's all encrypted on the blockchain itself. Only the nodes participating in consensus, the ones with the SGX enclaves, have the necessary keys to decrypt that data.
They only decrypt it inside the secure enclave.
Correct. Only inside the T for processing. The source mentions they use sophisticated key derivation methods, basically smart ways to generate all the needed keys securely and specific encryption for both the transaction data and the stored contract state.
So it's encrypted at rest, encrypted in transit.
And protected during computation by the SGX. They also mention something called consensus seed rotation.
What's that?
Sounds like they regularly change the core cryptographic secrets or keys used by the nodes. Adding another security layer makes it harder to break in long term.
Okay, wow. So encrypted data goes in, gets decrypted and processed securely inside the SGX black box where no one sees it, and then any results or changes get re-encrypted before leaving the box.
You got it. And that whole setup, the T's, the encryption, the key management, that's what they refer to as the confidential computing layer for the blockchain.
Confidential computing layer, I like that. It means the fact that something happened on the chain is public, you can see a transaction occurred.
Right. The metadata might be public.
But the details, what was sent, what the contract actually did, the result, that stuff stays private by default.
Exactly. Private by default.
Okay, but hang on. If it's all private, how do you use it? How do you, like, prove you own something private or share results selectively? Doesn't that break the whole point of blockchain being verifiable?
That's a really good question, and it leads right into their access control features. The source talks about viewing keys and permits.
Viewing keys. Okay, what are those?
Think of them as special keys you can create that grant read-only access to specific parts of your private data. Say you have a private token balance. They have this SNIP 20 standard, like ERC20, but private.
Uh-huh.
You could generate a viewing key just for that token balance and give it to, say, an auditor or maybe an app you want to use. Only the person with that key can then see your balance.
Ah, I see. So I control who gets to peek at my private stuff. It's not globally public, but it's not totally locked away either. You can grant selective access.
Exactly. Programmable privacy. You decide the visibility. And permits sound like a related idea, maybe for more temporary or one-off access without handing out a longer-term viewing key.
Okay, that makes a lot more sense. It gives the user control back. So you combine this privacy tech with these access controls.
Yeah.
What kind of things does this actually let people build? Things that were, like, impossible before?
Well, the source gives some classic examples. Confidential voting is a big one. Your vote gets recorded securely but stays secret.
Until the results are revealed by the contract itself, I guess.
Right. Then there are sealed bid auctions. You submit your bid, nobody else sees it, no front-running possible. The contract opens them all at the end.
Nice. What else?
They mention private randomness using something called secret VRF, the verifiable random function. Because the process happens privately inside the enclave, you can generate random numbers on-chain that are genuinely unpredictable and can't be manipulated easily.
Oh, that's interesting for gaming and maybe lotteries.
Definitely. And secure data storage, too. Imagine storing sensitive personal info or business secrets inside a contract and using the contract's logic to control access or run private computations on it.
So you could, like, analyze sensitive medical data without actually revealing the raw data to anyone?
That's the kind of possibility it opens up, yeah.
Yeah.
It really shifts what you can think about building in a decentralized way. The source mentions potential across DeFi, digital art, gaming, payments, communications, basically anywhere privacy matters.
And going back to the Cosmos SDK thing, how does it connect to other chains? You mentioned IBC, but what about, say, Ethereum or Solana?
Yeah, the source explicitly mentions toolkits they've built for interacting with other big ecosystems, specifically IBC for Cosmos chains, but also EVM for Ethereum and chains like it.
Like Polygon, Binance Smart Chain.
Right, and also Solana. So the idea seems to be that you don't have to build everything on Secret Network.
Okay, so how would that work? Could someone on Ethereum, like, call a function on Secret Network privately?
That seems to be the implication. They mention things like IBC hooks and cross-chain messaging. It points towards hybrid applications. Maybe your assets live on Ethereum, but you send a message to a secret contract to do some private calculation.
And then get a result back, maybe privately too.
Exactly. You use Secret Network for the confidential parts, leveraging its unique strength while keeping other parts of your app on different chains. Kind of a best of both worlds approach.
It sounds like they've managed to build up a bit of an ecosystem around this too. The source said something about dApps and builders.
Yeah, it mentions over 30 dApps running on mainnet already, and over 100 full-time builders working in the ecosystem. That's pretty significant.
And tools to help them build.
Yep. Things like secret.js and secret.py libraries for developers, plus local testing environments, wallets, the usual stuff you need to actually build things. And they mention bounties and grants, trying to encourage more development.
So it's not just the core tech. There are actual applications and people building on it.
Which is crucial, right? Shows it's being used.
And then the whole thing is powered by their native token, SCRT, used for fees, staking, governance.
Correct. Standard proof-of-stake model. SCRT fuels the network, secures it through staking, and lets holders vote on its future.
Okay, so let's try and wrap this up. Based purely on the material we've looked at for this deep dive, what's the absolute core thing to understand about Secret Network?
I'd say the main takeaway is that it provides this working confidential computing layer for Web3. It uses that mix SGX enclaves, encryption, key management to make smart contracts private by default.
Right, privacy not just for data sitting still, but privacy during computation itself.
Which is the really unique part.
And because of that, it enables these use cases that are just really hard or impossible on transparent chains. We talked about private voting, sealed auctions, real on-chain randomness, secure data handling.
Yeah, things where privacy isn't just nice to have, it's essential for the application to even work.
And it seems like there's a real ecosystem growing, developers are building, and importantly, it's designed to connect and bring these privacy features to other major blockchains like Cosmos, Ethereum, Solana.
Exactly. It's not just an isolated island, they're building bridges.
So final thought then. We see this constant push for more data privacy everywhere else, right? But most blockchains are fundamentally transparent.
Yeah, it's a tension.
So what happens long term when you have a platform like Secret Network that offers genuine, programmable privacy for smart contracts? How could that fundamentally shift the kinds of dApps we see? What new possibilities might open up that we haven't even thought of yet?
That's the big question, isn't it? If you can compute on data without revealing it,
Yeah.
what does that unlock down the road? Definitely something to think about.